Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Wireless networks come in many forms, and the topology you choose defines how devices connect, communicate, and roam across the environment. In episode 117, titled Wi-Fi Topologies, SSIDs, and Antenna Types, we explore the structure and identification of wireless networks, along with the role of antenna design in shaping signal coverage. Topologies, like basic service sets and extended service sets, determine whether your network serves a small room or an entire building. Meanwhile, antennas control how far and in what direction your signal reaches, and SSIDs help users locate and connect to the right network. These elements are vital for configuring a reliable wireless experience and are regularly tested on the certification exam. Service set identifiers, or SSIDs, are just as critical as topology in defining how wireless users interact with a network. An SSID is the name you see when you scan for Wi-Fi networks, and it represents a logical broadcast that ties clients to an access point. Behind the scenes, antenna types determine whether that access point serves one room, one floor, or one building. From performance to security, these components shape every aspect of the wireless deployment. On the exam, expect to see questions on how SSIDs behave, how topologies are structured, and when to use specific antenna types for different environments. The most common wireless topology is the Basic Service Set, or BSS. This setup consists of a single access point connected to a group of wireless clients, such as laptops, phones, or printers. Each BSS is identified by a unique BSS ID, which is typically the MAC address of the access point's wireless radio. This topology is simple and effective for small networks where clients do not need to roam between multiple coverage areas. On the exam, BSS may appear in questions focused on wireless basics or scenarios with standalone access points. In enterprise environments, a more advanced topology is used, the Extended Service Set, or ESS. This design includes multiple access points that share the same SSID and are connected to a central distribution system, typically over wired Ethernet. Clients can roam from one access point to another without losing connectivity, as the network sees all access points as part of the same logical wireless service. This seamless handoff is essential for large campuses, hotels, or multi-floor office buildings. The certification exam may present diagrams of ESS designs and ask how roaming or channel planning is managed. For environments that do not require central coordination, the Independent Basic Service Set, or IBSS, offers a peer-to-peer model. In this ad hoc network, devices communicate directly with each other without an access point. Each device participates equally in maintaining the network, making it useful for temporary or mobile setups. However, IBSS lacks many features of infrastructure mode, such as centralized security or bandwidth control. In the exam, you may be asked to distinguish between infrastructure-based BSS, or ESS, topologies, and the independent nature of IBSS. The Service Set Identifier, or SSID, is the public-facing name of a wireless network. It is configured on the access point and broadcast regularly so that nearby clients can discover and join the network. An SSID may represent a corporate network, a guest network, or any other logical grouping of users and devices. While it is possible to have multiple SSIDs on the same access point, each represents a distinct wireless network, often linked to separate VLANs or access policies. On the exam, understanding what an SSID is and how it is used to organize wireless access is fundamental. Some wireless networks choose to hide their SSIDs from public broadcast. A hidden SSID does not appear in the list of available networks when a client scans, but it can still be joined manually by users who know the name. This feature is sometimes used for minor obfuscation or to reduce visibility, but it does not provide real security. Hidden SSIDs are still discoverable with packet analysis tools and do not prevent unauthorized access on their own. The certification exam may include questions on the limitations of hidden SSIDs and the reasons for using or avoiding them. Modern access points can support multiple SSIDs simultaneously, each mapped to a different virtual network. This allows one physical device to provide separate wireless services for different user groups. For example, one SSID might offer secure employee access, while another offers Internet-only guest access. These logical networks are often linked to different VLANs and can have distinct authentication or firewall rules. On the exam, expect to see questions about how access points manage multiple SSIDs and how they can be used for network segmentation. Wireless networks can be either open or secured depending on the configuration of the SSID. An open network allows any device to connect without providing credentials, which is common in public places like airports or cafes. A secured SID requires devices to authenticate using a shared key or enterprise credential. Common security standards include Wi-Fi Protected Access 2, or WPA2, and Wi-Fi Protected Access 3, or WPA3. These protocols ensure that traffic is encrypted and users are authenticated. Certification questions may focus on identifying the differences between open and secured networks. Omnidirectional antennas are the most common type used in wireless deployments. These antennas radiate the wireless signal in all directions on a horizontal plane, providing broad circular coverage around the access point. This makes them ideal for general-purpose coverage in indoor environments like homes, classrooms, and small offices. They provide even distribution and allow devices to connect from multiple angles. The exam may ask when to use omnidirectional antennas and how their radiation pattern affects placement and performance. Directional antennas serve a different purpose by focusing the wireless signal in a specific direction. This concentration increases signal strength and range, making them ideal for point-to-point links or covering long corridors. Directional antennas are commonly used in outdoor installations, such as connecting two buildings across a parking lot. Their narrow beam reduces interference and increases efficiency, but requires careful alignment. On the exam, you may be presented with a scenario requiring extended range or focused coverage and be asked to identify the appropriate antenna type. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Antenna gain is an important measurement that reflects how well an antenna focuses radio frequency energy. This gain is measured in dBi, which compares the antenna's performance to an ideal isotropic radiator. A higher dBi value indicates a more focused signal, typically associated with directional antennas. Lower dBi values indicate a more even, omnidirectional pattern. While more gain can increase range and signal strength in a specific direction, it also narrows the coverage area. On the exam, you may be asked to compare antennas based on their gain ratings, or to choose the appropriate one for a given environment. Where antennas are placed can significantly affect wireless coverage. Ideally, antennas should be positioned to avoid obstructions, like walls or furniture, which can absorb or reflect signals. Elevating the antenna can improve line of sight and reduce interference. Placing antennas in central locations allows for more even coverage in all directions when using omnidirectional types. In contrast, directional antennas should be carefully aligned with their target area to ensure strong signal delivery. The certification exam may test your knowledge of best practices for antenna placement and how it impacts wireless performance. Multiple antenna technologies have improved wireless reliability and throughput, especially in modern Wi-Fi standards. MIMO, multiple input, multiple output, uses several antennas to transmit and receive data simultaneously, creating multiple spatial streams. This increases the amount of data that can be sent without consuming extra bandwidth. MIMO also improves performance in environments with reflections or interference. The exam may include questions about how MIMO enhances signal quality, supports higher throughput, or enables features like beamforming and multi-user transmission in recent Wi-Fi versions. Naming conventions for SSIDs may seem simple, but they carry significant impact on user experience and network administration. Descriptive names help users identify the correct network quickly, while vague or misleading names can cause confusion. It is also important not to disclose sensitive information such as company names, device models, or locations. within the SSID, as this can aid attackers during reconnaissance. Consistent naming schemes across multiple sites or access points simplify troubleshooting and roaming behavior. On the exam, you may be asked to choose the most appropriate SSID naming strategy for a given organization. Wireless bridging is a common application of directional antennas, especially in outdoor environments. In a wireless bridge setup, 2 or more locations are connected wirelessly using point-to-point links. This allows networks in separate buildings to communicate without requiring underground cabling. These links require clear line of sight and must be aligned precisely. Directional antennas like Yagi or parabolic dishes are often used to establish these long-range connections. On the exam, questions may describe a scenario involving building-to-building connectivity and ask which antenna type or topology is best suited for the job. Mesh networking is a topology that extends wireless coverage by having access points communicate wirelessly with one another. Unlike traditional setups, where each access point connects to a central switch, mesh access points can relay traffic between each other. This is especially useful in environments where cabling is impractical, such as outdoor parks, warehouses, or temporary setups. Mesh networks are also self-healing, meaning they can reroute traffic automatically if one node goes offline. The certification exam may present mesh networking as a solution to coverage challenges or as an example of scalable wireless design. Understanding antenna types and their roles is a common topic in exam contexts. You should be able to identify when to use omnidirectional antennas for general coverage or directional antennas for focused links. You must also match these antennas to different physical environments, such as open indoor areas, hallways, or outdoor point-to-point scenarios. Additionally, linking antenna characteristics to real-world deployment goals, such as signal coverage shape or range optimization, is key to selecting the correct equipment. Exam questions often focus on these practical distinctions to test applied knowledge. In summary, wireless network design depends on the interaction of topology, SSIDs, and antennas. The topology determines how devices connect and how users move across the network. The SSID identifies the network and controls how clients join, while antennas determine how the signal is broadcast and received. Together, these elements define coverage, performance, and user experience. Understanding their behavior, configuration, and limitations will help you not only pass the certification exam, but also design better wireless environments in the real world. To conclude episode 117, Wi-Fi topologies, SSIDs, and antennas form the foundation of wireless network functionality. Choosing the correct topology enables proper communication and scalability. Configuring meaningful and secure SSIDs helps users connect easily while maintaining control. Selecting the right antenna ensures that coverage reaches exactly where it's needed, with the right balance of range and focus. These design elements are critical for creating high-performing, reliable wireless networks and are key areas of knowledge required for certification success. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.